Hey you guys, it's Miss Latham, and I just wanted to finish going over some examples from the Trig Identities lesson. So let's get started. For the first one, they want us to find the tangent of pi over 12, and we know that pi over 12 is not a radian measure that's on the unit circle. So what we want to do is think of two radian measures that we could add or subtract that would give us pi over 12. And that kind of sounds daunting, but let's think about pi over 12 as a degree, and it's not as difficult. So if we convert pi over 12 to degrees, we would multiply pi over 12 times 180 over pi, and then those pi's will cancel out, and 12 goes into 180 15 times. So pi of 12 radians is just 15 degrees. And I bet you could think of 2 degrees on the unit circle that we could subtract and get 15. What would that be? That would be 45 degrees minus 30 degrees. So we just want to think of this as the tangent of, now we need to use our radians. So 45 degrees is how many radians? So that'll be pi over 4. Minus 30 degrees, which is pi over 6. And we're going to use the formula for the tangent of differences. So that'll be the tangent of pi over 4 minus the tangent of pi over 6. And that'll be divided by 1 plus the tangent of pi over 4 times the tangent of pi over 6. All right, and then we just plug in the values from the unit circle. So the tangent of pi over 4, that's where sine and cosine are both the square root of 2 over 2, so that'll be 1 minus, and then for the tangent of pi over 6, that would be 1/2 on top of the square root of 3 over 2, which would be 1 over the square root of 3, or the square root of 3 over 3. And that's divided by, and then y'all, it's just these same values we're going to plug in here. So 1 plus 1 times the square root of 3 over 3. All right, I'm going to do a common denominator. So I know that 1 is the same thing as 3 over 3. So this would be 3 minus the square root of 3 over 3 divided by. And then 1 times anything is itself, so I'm going to pretty much do the same thing. 1 here could be this 3 over 3. So we would have 3 plus the square root of 3 over 3. And then these 3's will cancel, and you're left with 3 minus the square root of 3 over 3 plus the square root of 3. And it turns out that on Pearson, they are just happy as they can be with that radical in the denominator, so we are not going to worry about it, okay? All right. Let's try another one. This time they want me to do the sine of 5 pi over 12. So, I'm sorry you guys, I'm trying to move this light. All right, again, 5 pi over 12, not on the unit circle, but if we think about that in degrees, that would be 75 degrees. So are there any degree measures that we could add or subtract and get 75 degrees? And we could do 45 and 30 again, but we'll just be adding them. So I'm going to do 30 degrees plus 45 degrees. Or the sine of, so 30 degrees is pi over 6. Plus 45 degrees is pi over 4. And then I'm going to use the formula for the sine of a sum. So that will be the sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. And then I'm just going to plug those values in off the unit circle. So that would be the sine of pi over 6 is 1/2. The cosine of pi over 4 is the square root of 2 over 2 plus The cosine of pi over 6 is the square root of 3 over 2. And the sine of pi over 4 is the square root of 2 over 2. And then we're just going to clean that up a little bit. So that'll be the square root of 2 over 2 times 2 is 4. Plus the square root of 3 times the square root of 2 is the square root of 6. 2 times 2 again is 4. I'm going to write that numerator as one expression. And we're finished. Okay. All right, let's move on to another one. All right, the next one is a word problem. All right, it says there is a guy wire d feet long with a shadow defined by L equals d times the sine of theta minus 90 over the negative sine of theta. Show that this is equivalent to L equals d times the cotangent of theta. So they're basically telling us they want us to verify that these two things are equal. So let's do a verification. So I'm going to write all this. I'm going to scoot up just a little bit here. D sine of theta minus 90 over the negative sine of theta equals d times the cotangent of theta. And I'm going to make this side look like this side. So focus right here. We got the sine of theta minus 90. Where have we seen that before? That is one of your cofunction identities. So right down here, look, the sine of pi over 2 minus theta are, flip-flopped around a little bit there. So I can think of this as d times the cosine of theta over the sine of theta. And that would actually be a negative d since I flipped the formula around. And then you had the negative on top where I changed this around and the negative on bottom because it's usually the sine of 90 minus theta, right? So the negatives will cancel, and then cosine over sine is cotangent. So we use the formula for the cofunction, except it was switched around, so we pulled the negative out. Remember, sine is an odd function, so we pulled the negative out front. We had a negative on top and a negative on bottom. They canceled each other out. And then cosine over sine is cotangent. And we're done. Okay, let's look at the next one. Get that lined up. All right, we have the cosine of 5 pi over 4 minus 11 pi over 6. And I'm just going to plug the values in and evaluate for the cosine of a difference. So that would be the cosine of 5 pi over 4 times the cosine of 11 pi over 6 plus, because it's the opposite, the sine of 5 pi over 4 times the sine of 11 pi over 6. All right, and now we want to plug in the values. 5 pi over 4 would be over in quadrant 3. That is negative the square root of 2 over 2. All right, and then we got that times the cosine of 11 pi over 6. 11 pi over 6 is all the way in quadrant 4, and that would be the square root of 3 over 2. All right, again, 5 pi over 4 is in quadrant 3. The sine of 5 pi over 4 is negative the square root of 2 over 2. And then times the sine of 11 pi over 6, again in quadrant 4. And 11 pi over 6 for sine would be negative a half. And we just want to clean it up a little bit. So negative square root of 2 times the square root of 3 would be negative the square root of 6 over 4. 2 times 2 is 4. And then negative, negative, that's going to come out to be a positive. The square root of 2 times 1 is the square root of 2 over 4. So that's negative the square root of 6 plus the square root of 2 over 4. All right, let's move on to the next one. Let me scoot this over so I'm sorry about that. Okay. All right, and then the last two. All right. We've got the cosine of 5 pi over 12 minus pi over 4. Well, 5 pi over 12 is not on the unit circle. So what I'm going to try to do is put these together. Just go ahead and subtract them and see what happens. So if you've got 5 pi over 12 and you want to subtract pi over 4, you got to have a common denominator. So I'm going to make the 4 12 by multiplying by 3. So I'm going to multiply the top by 3. So 5 pi over 12 minus 3 pi over 12 is 2 pi over 12, which is pi over 6. So really all it's asking me for is the cosine of pi over 6. That is easy breezy lemon squeezy. That is going to be the square root of 3 over 2, and that problem is done. And now for a good one. Okay. So we got the cosine of s is 1 over 5, and the sine of t is 3 over 5. We know that they're both in quadrant 1, so that's fabulous. Everything is positive. They want us to find the cosine of s plus t. So we know that the formula for the cosine of s plus t would be the cosine of s. I don't like having those two s's. Times the cosine of t, and then it'll be a minus the sine of s times the sine of t. All right, so I have the cosine of s, but I don't have the cosine of t, and I've got the sine of t, but I don't have the sine of s, so we have got to find those things. So we're going to start by using x squared plus y squared equals r squared. So cosine is x over r. So for s, we would have 1 squared plus y squared equals 5 squared. So 1 plus y squared equals 25. Subtract 1, and we get y squared is 24. So y would be the square root of 24. And we could actually simplify that because that's 4 times 6. So that would be, oh my goodness, I'm sorry. That'll be 2 times the square root of 6. All right, now let's do it for the sine. So sine is y over r. So we would have x squared plus 3 squared equals 5 squared. We're very familiar with this one. So x squared plus 9 equals 25. Subtract 9. We get x squared equals 16. So x is going to be 4. And like I said, we're in quadrant 1 and everything is positive. So now that we have our y and we have our x, we can do this. So, all right, the cosine of s is 1/5 times the cosine of t would be x over r, and then minus the sine of s. So I'll come over here. We got that y is 2 times the square root of 6 over r is 5 times the sine of t is 3 over 5. All right, 1 times 4 is 4. 5 times 5 is 25. And then 2 times the square root of 6 times 3, you do the 2 outside here. 2 times 3 is 6. So that's 6 times the square root of 6 over 25. And then I'm going to put those together. That'll be 4 minus 6 times the square root of 6 over 25. And that'll be it. All right, I'll talk to you guys later. Have a great day.